To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today also I am going to continue with electrolysis of aqueous solution. So you can remember in the previous chapter we discussed electrolysis of molten or fused sodium chloride, and thereafter I discussed electrolysis of sodium chloride aqueous. There you were able to understand that depending on the electrolyte, if it is the sodium chloride liquid, there is a set of products. And when it is the sodium chloride aqueous solution, because of the ions present in the electrolyte, the reactions and the products of electrolysis is different. So I'm sure you all can remember that. So now I'm going to discuss electrolysis of an aqueous copper sulfate solution. So we will discuss that after observing the activity. Activity: study the changes taking place during electrolysis of an aqueous copper sulfate solution. So here you can remember the chemical formula CuSO4 aqueous, that is copper sulfate solution. And to do this activity, these are the materials that we need. Here you can see in a beaker we have copper sulfate solution. Copper sulfate solution. Copper sulfate solution. Then we need carbon rods as the electrodes. Connecting wires. Connecting wires. And also we need a battery. A 9 volt battery, a dry cell, or if you can get a power supply with 9 volts, that is also fine. So we need copper sulfate solution, carbon rods, connecting wires and batteries, and also we will need crocodile clips to connect the electrodes with the connecting wires and the battery as well. So that is what we need. This is what we are going to do. We are going to connect the carbon rods using the connecting wires to the battery, and then you insert that into a solution of copper sulfate, and then you observe the changes. Now here of course copper sulfate, like you all know, is a blue color solution. So you need to observe all the changes taking place during electrolysis. So I'll move on to the next slide where I discuss the procedure again, the method. So this is the method. This is the setup for the activity. So here you can see this is carbon electrode. Carbon electrode. Or we can write it as carbon rod. Here also it is a carbon electrode. Electrode. And here we have copper sulfate aqueous. You can write it in words also, aqueous solution of copper sulfate or CuSO4 aqueous. And you all know when we connect this electrode to the positive terminal, that becomes the positive electrode. And here this second carbon rod connected to the negative terminal becomes the negative electrode. And also you all know the solution is blue in color. There is a color for the solution. Copper sulfate solution is blue in color. So when we carry out the electrolysis process, once everything is connected and the electrodes are dipped into the solution, electrolytic process will start, and then you have to look at the observations. So here you need to observe the positive electrode, the negative electrode, and also the solution in order to observe the changes. Is that clear, students? So if we look at the process, connect the electrodes to the battery as follows. So that is shown above. Then dip the two electrodes in the copper sulfate solution and observe. Record your observation. So that is the activity. Let us go to the lab and do the activity now. Okay, students. So now we will observe what happens when we try to electrolyze an aqueous solution of copper sulfate. So an aqueous solution of copper sulfate is an electrolyte solution. It conducts electricity. So you all know the color of copper sulfate. It is a blue color solution. So copper sulfate solution. Now when we say copper sulfate solution, copper sulfate is dissolved in water. So there are ions, Cu2 plus ions and H plus ions. Those are the positive ions or cations present in the solution. Then there is hydroxide ion from water, OH minus, and sulfate ion from copper sulfate. Both are negative ions or anions. Then I have the dry cell here. This is a 9-volt battery. You can see the terminals. The negative terminal is connected to this carbon graphite electrode. So this becomes the negative electrode, or what we call as the cathode. You all know, students, the electrode near which the reduction process takes place is known as the cathode. So here the negative electrode is the cathode. So the reduction will take place near cathode. And here you can see the positive terminal that's connected to this electrode. So that becomes the positive electrode, and there it is known as the anode. Anode is the electrode where oxidation takes place. That is the convention. You all are familiar with that. And also you all already know, students, the negative ions in the solution migrate towards the positive electrode and the positive ions migrate towards the negative electrode. So now we will see what happens when we dip the two electrodes in copper sulfate. So here I have copper sulfate. You all have to observe the color of the solution since the solution is colored, and also you all have to see what happens near the electrodes. Now here you can see both the carbon electrodes, the graphite electrodes are clean. You see the color of graphite only. Now I will dip them in the solution. We have to make sure the electrodes do not touch each other, and you all have to observe what happens there. It takes a little time for the change to start. Can you all see near the positive electrode? There are small gas bubbles forming near the positive electrode and the negative electrode. So here you all can see, students, near the positive electrode there are gas bubbles. So near the negative electrode, this is the cathode, that is with the black color clip, that is the cathode. Near the cathode also you all can see a slight color change now. You can see a light brownish color layer forming near the cathode, that is the negative electrode. And near the positive electrode, that is the anode, you can see the liberation of gas bubbles. Can you all see those changes clearly? So students, with time you all can see near this one, the red color clip, that is the positive electrode or the anode, you see the evolving of gas bubbles. You all can see gas bubbles around the electrode. And then the negative electrode, that is the black color clip, there, that is the cathode, you can see the depositing of a brownish color layer. So there are copper deposits on the negative electrode. Copper ions are positive ions. They migrate towards the negative electrode and they take up electrons and deposit as copper metal. So that is a reduction process. So therefore, the negative electrode is the cathode there. At the same time, near this red color clip, that graphite electrode is connected to the positive terminal. The negative ions, here we have sulfate ion and OH minus ion, both migrate towards the positive electrode, but out of those, the OH minus ion gets oxidized and there is oxygen gas being evolved near the positive electrode. So near the positive electrode, oxygen gas is evolved. Near the negative electrode, copper deposits. And also, with time, you all can observe, you would have seen the change to a certain extent. The blue color of the copper sulfate solution decreases. Can you all see a small change there? Initially, the color was more intense. Now the color has become a little more lighter. And with time, if you continue doing this process, the color will further decrease. So for that, we have to wait for some more time. So here, if I take out the electrodes, you can see the copper deposited on the negative electrode, that is the cathode. That is very clearly visible. Now you can see the color there. The brownish color deposit, that is the copper deposited on the negative electrode. Okay students, now can you all see? Now I have been having the electrodes inside the copper sulfate solution for some time now. Now you all can see a more better color change. You can see the color of copper sulfate has decreased to a great extent compared to the initial solution. So if you continue this process, if we do this electrolysis for a very long time, then of course the color of copper sulfate will be completely disappeared. It will become colorless. So, and at the same time, you were able to see the deposit of copper here. At the cathode, that is the negative electrode, you can see copper depositing, a brown color deposit. At the same time, you saw the evolving of gas bubbles near the positive electrode, that is anode. And also you saw the color decrease. Blue color of copper sulfate decreases with time and finally it will become colorless. So that is what happens when we carry out electrolysis. So this is what happens if we carry out electrolysis of copper sulfate. You can see the copper deposited there. So those are the observations. You have to remember 3 observations. Copper deposits on the negative electrode, gas bubbles evolve near the positive electrode, color of copper sulfate decreases. That is, the blue color of copper sulfate decreases, and if we carry this on for a long time, the color will completely disappear. It will become a colorless solution. Okay students, so what were the observations? You were able to see the deposit of copper near the negative electrode. That is the cathode. Negative electrode is the cathode, and on the cathode you were able to see the deposit of copper. That is, a brown color deposit was observed on the cathode, that is the carbon electrode. And near the positive electrode, that is the anode, you were able to observe the liberation of gas bubbles. And also, we took the copper sulfate solution, which was blue in color, and with time, you were able to observe the gradual decrease in blue color of the solution. So there are 3 observations for this particular activity. I will write them down here. Copper deposits at the negative electrode, that is cathode. And then you can remember liberation of gas bubbles, liberation of gas bubbles at the positive electrode, that is the anode. And also you were able to see decrease in blue color of the copper sulfate solution gradually. It does not completely go off quickly, but it takes time. So gradually the color decreases, and like I told you all, if we keep on doing the electrolytic process for a longer period of time, then the blue color will be completely lost. We will get a colorless solution. So that is the observation. So copper deposits at the negative electrode, that is the cathode, liberation of gas bubbles at the positive electrode, that is the anode, and decrease in blue color of the copper sulfate solution gradually. So those are the observations. Now we will try to understand the reactions taking place that cause these three observations. So then in the next slide, now here we have the electrolytic cell. In order to understand these observations, let us consider the reactions involved in here. So here, as you can see, positive and negative electrodes. So this is carbon rod. That is also carbon. So here we have copper sulfate aqueous. Now when we say copper sulfate aqueous, you all know copper sulfate can dissociate completely. Why? It is an ionic compound. So there is Cu2 plus ions and sulfate ions. In addition to that, it is the aqueous medium. So in the previous process also, you all can remember, we discussed that normally also water dissociates, but a small quantity dissociates. But when it is in the aqueous solution, there is dissociation of water, H plus and OH minus ions. So Cu2 plus, H plus, those are the positive ions. And SO4 2 minus and OH minus, those are the negative ions. So from this, what will happen? The positive ions will migrate towards the negative electrode. So they are Cu2 plus and H plus will move towards the negative electrode. At the same time, sulfate ions, SO4 2 minus, will move towards the positive electrode. At the same time, OH minus also moves towards the positive electrode. Is that clear, student? Then what do we need to consider? You need to look at the two metal ions, hydrogen ion and copper ion. Consider the activity series. I am sure you all can remember, after hydrogen only we have copper. So copper is less reactive. That means copper will undergo reduction. So there you have to remember copper, because it is less reactive than H plus ions, copper will undergo reduction, not hydrogen. You have to remember. Because copper is less reactive, Cu2 plus will get reduced. At the same time, there are two negative ions, two anions, sulfate ion and hydroxide ion. Out of that, the hydroxide ion will undergo oxidation. So those are the reactions that are going to take place here. So if we write that, now both OH minus ion and H plus ions. So in the solution, we will have H plus and sulfate remain. So let's look at the changes. So if I say near the negative electrode, what will happen? Cu2 plus goes towards the negative electrode. It will take up electrons. Here you can see 2 plus, so they need 2 electrons and it becomes Cu solid. So this is what deposits at the negative electrode. Brown color deposit, reddish brown color or brown color deposit. So that is one reaction. So this is a reduction or cathodic half reaction. So this is the deposit of copper, you can remember. So here, this is the deposit of copper at the cathode. Then, near the positive electrode, what happens there? The OH minus ions migrate towards the positive electrode. Now, when we have OH minus aqueous, you have to remember this equation, students. OH minus becomes H2O liquid plus O2 gas by losing 4 electrons. In order to get that, we need to have 4 OH minus ions and 2 water molecules will be produced. So you have to remember this equation. 4 OH minus aqueous gives rise to 2 H2O liquid plus O2 gas and 4 electrons. So oxygen gas, that is the liberation of gas bubbles near the positive electrode. So gas bubbles, that is oxygen. You have to remember that. Here it is oxygen gas bubbles. And also if you see Cu2 plus 2 electrons, and there are 4 electrons being released. So what do we need to do? We need to multiply this first equation by 2 so that the number of electrons become 4 electrons. So that we can add the equations and balance them without any electrons. So here you have to remember that also. There are 2 electrons here and there are 4 electrons there. Because of that, we need to multiply the first equation by 2. So then this is what you will get. Now here we will take this as the second equation. So when you multiply this equation by 2, you get 2Cu2 plus aqueous taking up 4 electrons giving rise to 2Cu solid. That is the equation there. Then if we label that as 3, now you can add up the second and the third equation. 2 plus 3 will give rise to 2Cu2 plus aqueous plus 4OH minus aqueous. We are adding these two, this one and this one, plus 4 electrons gives rise to, you can see there, 2 H2O liquid plus O2 gas plus 2 Cu solid and 4 electrons. Now out of these, here we have 4 electrons before the arrow and 4 electrons after the arrow. So we cancel them off. And finally, you get the equation 2Cu2 plus aqueous plus 4OH minus aqueous giving rise to 2 water liquid plus O2 gas plus 2 Cu solid. That is the overall reaction. Can you all understand that? So 2 plus ions, that is copper ions and hydroxide ions, undergo reduction and oxidation respectively. So that is the overall electrolytic reaction. Is that clear to you all? So we get oxygen gas bubbles evolving at the positive anode, and there it is the copper depositing at the negative cathode. So you can remember that. So those are the observations. O2 gas bubbles are liberated near the positive anode and brown color copper deposits at the negative cathode. So why does the blue color of solution decrease? Now in this reaction, Cu2 plus aqueous, that is copper from copper sulfate solution, deposits as copper solid. So the amount of copper ions in copper sulfate decreases. Therefore, the color decreases gradually. So what are the ions that will remain in the solution? If you remember, there was H plus ions and sulfate ions. So both of those will remain in the cell. So that is also something you need to remember. When Cu2 plus gets removed from copper sulfate, the blue color decreases. So when H plus ions and sulfate ions remain in the electrolytic cell. Electrolytic cell. Is that clear, students? So we'll quickly look at the process again. Now this is what happened. Initially we had Cu2 plus, sulfate, H plus and OH minus. Out of that, Cu2 plus goes near the negative electrode, gets reduced and deposits as copper on the cathode. And near the anode, that is the positive electrode, OH minus ions get oxidized. Their oxygen gas will be liberated. These are the reactions taking place. Here you can see H plus and sulfate remaining. So that is what I told you all. H plus and sulfate ions remain in the electrolytic cell. So near the negative electrode, copper takes up electrons, deposits as copper solid. So that is the reduction or cathodic half reaction. Then near the positive electrode, 4 OH minus ions get oxidized to become 2 water molecules, 2 H2O liquid and 1 oxygen gas, O2 gas, losing 4 electrons. In order to balance the reactions, we need to multiply the first reaction by 2. So that becomes 2 Cu2 plus aqueous plus 4 electrons becoming 2 Cu solid. When you add 2 and 3 together, you get 2 Cu2 plus aqueous plus, here you can see the second equation and the third equation, 2 Cu2 plus aqueous plus 4 OH minus aqueous plus 4 electrons becoming 2 H2O liquid plus O2 gas plus 2 copper solid and 4 electrons. So the 4 electrons get cancelled off and finally you get this equation. 2 Cu2 plus aqueous plus 4 OH minus aqueous gives rise to 2 H2O liquid, O2 gas and 2 copper solid. Here you can see these are the observations. Oxygen gas bubbles are liberated near the positive anode. Brown color copper deposits at the negative cathode. And when copper gets removed from copper sulfate, the blue color decreases. So those are the 3 observations that we got. And also H plus and sulfate remain in the electrolytic cell. So initially it was copper sulfate, blue color solution. But you know sulfuric acid, H plus and SO4 2 minus, sulfuric acid, that is colorless. And when the copper ions are being removed, gradually you see the decrease in blue color. So now can you all understand that clear? So then let's move on to the next slide where again in order I will write these equations. Reaction at the negative electrode, that is the cathodic reaction. Both copper and H plus ions migrate towards the negative electrode. So here also there are two ions, copper and H plus ions migrate towards the negative electrode. And as copper lies below hydrogen in the activity series, copper ions have a greater tendency to get reduced. So that is why copper ions get reduced. And the reaction you can remember Cu2 plus aqueous plus 2 electrons giving rise to Cu solid. Here to balance the 2 plus we need to have 2 electrons. Hence copper is deposited on the cathode. So hence copper is deposited on the cathode. As this is a reduction reaction, one is the cathodic reaction. So here we will label this as the first equation. So that is the cathodic reaction. Thus, negative electrode is the cathode. You all can remember that. As Cu2 plus ions responsible for the blue color of the solution are removed from the solution, the intensity of the blue color of the solution decreases. So this is something you have to remember, students. As Cu2 plus ions responsible for the blue color of the solution are removed from the solution, the intensity of the blue color decreases. That is what I explained to you all. Then, in the next slide, reaction at the positive electrode, that is the anodic reaction. So here you can see sulfate and OH minus ions in the solution are attracted towards the positive electrode. Of these, OH minus ions have higher tendency to be oxidized. So you can remember the equation. For OH minus aqueous becomes 2H2O liquid plus O2 gas, losing 4 electrons. Is that clear, students? So therefore, oxygen gas bubbles evolve at the anode. Reaction 2, we have to label it as reaction 2. This is reaction 2. Therefore, oxygen gas bubbles evolve at the anode. Reaction 2 is an oxidation. So, it is the anodic reaction. Hence, positive electrode is the anode. So, these are things that you already understood. So, then I'll move on to the next slide. So, this is for your memory file. Since the amount of H plus ions in water is negligible, sometimes the reaction 2H2O liquid plus 2 electrons giving rise to 2OH minus aqueous and H2 gas is considered the more fitting cathodic reaction than 2H plus aqueous plus 2 electrons giving rise to H2 gas. I will read everything and explain to you all. Similarly, the anodic reaction 2H2O liquid giving rise to O2 gas and 4H plus aqueous plus 4 electrons is more appropriately used in place of 4OH minus aqueous giving rise to O2 gas, 2H2O liquid and 4 electrons. Now you can remember these two equations, students. Now when we wrote some of the equations, 2H plus aqueous plus 2 electrons giving rise to H2 gas. And the other one, 4OH minus aqueous giving rise to 2H2O liquid plus O2 gas losing 4 electrons. Now these are two equations, two half reactions that are familiar to you. This is the reduction half reaction where H2 gas is formed. And here it is the oxidation half reaction where oxygen gas is formed. Now in these two, you can see here, students, these two ions, H plus and OH minus ion, are from water. So, if water liquid dissociates to give H plus and OH minus. Now, this is usually, what can we say? This is very, very small. That is, H2O dissociating to give H plus and OH minus is very, very small. Normally, the forward reaction is very less. Mostly, water remains as H2O liquid. So, because of that, what we can do is, instead of writing these two, now if this happens only, you will get H plus and OH minus. Instead of writing that, what we do is, we directly write. Instead of this reaction, we write as water liquid taking up 2 electrons, giving rise to H2 gas plus you get OH minus aqueous. So, to have that, we need to have 2 water and 2 OH minus. So, water molecules itself take up electrons, giving rise to H2 gas and OH minus. Instead of this dissociation, we take water as taking up electrons and evolving hydrogen gas. The same way, we can write for this one. So, here also we can write water liquid giving rise to O2 gas plus H plus aqueous losing 4 electrons. So, here of course we will have 4 H plus and 2 H2O liquid. So, that is the other reaction. Instead of this one, we consider that water molecules lose electrons. So, here you can see both are water molecules. Now, in this 2H2O liquid, here also 2H2O liquid, here of course 2 electrons are taken up, there are 4 electrons being lost. But in both, you can see the desired product. H2 gas is produced, O2 gas is produced. So, this is something you just need to remember, students. Because the dissociation of H2O to H plus and OH minus is very, very small. So, we can almost consider this as not taking place also. We saw, you can remember the value 1.0 into 10 to the minus 7 moles per decimeter cube. A very, very small amount. So, because of that, in place of this equation, we can write that one. And in place of the second equation, we can write this first equation. That is what I have shown there. Is that clear to you all? So, this is for you all to remember. So, these are what you need to remember. Normally, we write, so far we have been writing 2H plus aqueous plus 2 electrons, H2 gas. 4OH minus aqueous giving rise to 2H2O liquid plus O2 gas plus 4 electrons. But that is possible only if water dissociates. So, because of that, what we can do is, instead of the first equation, we can write this as water taking up electrons and getting reduced to give H2 gas and OH minus ions. At the same time, water losing electrons to produce O2 gas and H plus ions, that is oxidation. Is that clear to you all? So, this is for you all to remember, students. So, there I have completed the electrolysis of aqueous copper sulfate solution. Now, I will move on to the next type of electrolysis. So, then electrolysis of acidulated water. So, this also we will try to understand that using an activity. Activity, let us pay attention to the electrolysis of acidulated water using carbon electrodes. So again, you have to look at the electrolyte and the electrodes. Acidulated water using carbon electrodes. So how do we get this acidulated water? You have the distilled water. Into that, if you add a small amount of dilute sulfuric acid, we will get acidulated water. Why do we need to do that? You can remember water is a covalent compound, so it does not have any free ions. We discussed that in the previous slide also, very small amount. Because of that, it usually does not conduct electricity. So to make it to become a conductor and the dissociation to occur, we add dilute sulfuric acid. So it becomes acidified water or acidulated water. That can be electrolyzed easily. So to do this, these are the materials that we need. Here you can see we have dilute sulfuric acid, can say sulfuric acid mixed with distilled water. So a small amount of dilute sulfuric acid mixed with distilled water to get the acidulated water or acidified water. Then we have carbon rods or carbon electrodes. Then we have a battery. Then you can see we have connecting wires. And also we need a plastic cup here. Now this process is also electrolysis of acidulated water. Only thing is the electrolytic cell that we are going to use for this activity is going to be different from the previous activities. In all the previous activities, you can remember students, we had the beaker. In the beaker, we had the electrolyte solution and into that we dip the electrodes. But here, what we will do is we have the plastic cup. We need to take the plastic cup, make 2 holes enough to insert the carbon electrodes. You insert them into the plastic cup and you have to seal those holes so that the water does not leak. You can seal it using wax or you can use PVC or you can use silicone sealer. You can seal it in some way so that water does not leak from there. And after that, we connect the wires and the batteries from the electrode that is from the bottom of the plastic cup. And you take acidulated water into the cup. So it's going to be a different setup. I will move on to the next slide and explain it to you. So here you can see. Now this is the setup for the activity. As you can see, this is a 9-volt battery connected here. And you can see this is the plastic cup. Now first look at the plastic cup. Now there are 2 electrodes there. So these electrodes have been inserted from the bottom there. So these are the carbon electrodes, carbon rods. And this side also we have a carbon rod. They have been inserted from the bottom. And also we have acidified water. So you insert the carbon rods, you put wax around it so that you can seal it properly, so that water will not leak. And then the carbon rods are connected to a 9-volt battery. At the same time, you take the acidulated or acidified water into the plastic cup. And here you can see there are test tubes. You need to have 2 small test tubes filled completely with water without any air bubbles trapped inside, and you have to invert them over the electrodes. so that we can collect the gases that are evolved near the two electrodes. So with the materials, we need to have 2 test tubes as well. So I will go back here. You need to have 2 small test tubes. That is also needed for the activity. So this is how we prepare the setup. You can look at the procedure. Pierce the bottom of the plastic cup and fix the carbon rods as shown in the figure. Seal any spaces around the rods with a substance such as molten wax or PVC so that water does not leak. Even silicone sealer may also be used. So it can be molten wax, you heat the wax and you put it onto that, the liquid wax, it will solidify and it will seal it, or PVC or a silicone sealer. Add acidulated water to the cup. Introduce the 2 carbon rods into 2 inverted test tubes filled with the water as shown in the figure. So they are the test tubes completely filled with water. Supply electricity to the 2 carbon electrodes. Record your observations. So you have to remember, students, initially these are completely filled with water. Test tubes completely filled with water. Filled with water. Then you carry out the electrolytic process and thereafter you will get the observations. So while you do that, you have to observe the 2 electrodes. You have to look at the water level in the test tubes. Then you will get the observations clear. I'm sure you all can understand the procedure. So let us go to the lab and do this activity now. Okay, students. So now we will see the observations, or we will look at the activity where we carry out electrolysis of acidulated water. What is acidulated water? We take distilled water and to that we add a small amount of dilute sulfuric acid. So then we get the acidulated water. You all know the reason. Distilled water does not conduct electricity. So when we add a small amount of acid, there are free ions generated, and because of that, acidulated water becomes an electrolyte. So because of that, it conducts electricity. So inside this plastic cup, we need a plastic cup. In that I have acidulated water, and here you can see there are 2 carbon graphite electrodes fused from the bottom. From here the connection is given. If they are inserted, you make holes in the plastic cup and through that we insert the graphite electrodes, and then we have to seal the holes so that the water does not leak. Now here you can see there's no leaking of water. So to do that, you can either use silicone gum, PVC, or you can have some kind of adhesive that does not react, but you can use it to seal the cup. So that is how we make the electrolytic cell here. And you all can understand, students, this is somewhat different from the previous electrolytic cells that we used. Earlier we used the beaker with the electrode dipped into the solution. But here we have fixed the electrodes to the cup so that we can collect the gases. So to do that, we have 2 small test tubes here. What we need to do is we need to fill this with water and invert it onto the electrode. So to do that, I will fill it with water. We have to make sure there are no gas bubbles, and we have to invert it onto the electrode. So here I have inverted 1 test tube. The same way I will fill the other test tube also with water, and then we invert it and onto the electrode. So this is how we have the electrolytic cell set up there. So then we have a 9-volt battery here. So you can have a look at the terminals, the positive terminal and the negative terminal. And here I have a cover for the battery, so we can connect it easily. Now this side, the positive terminal will get connected to this part here, and the negative terminal gets attached to this part. And here there are 2 colored wires. The black color wire will be connected to the negative terminal like this, and the red color wire will be connected to the positive terminal. So when I attach it this way, there will be current flowing through the electrodes and the cell. So we will see what happens there. You all have to observe the changes taking place near the electrodes. So here I have connected the dry cell. You can see now this wire, black color wire, is connected to blue here. So this becomes the negative terminal and this is the positive terminal. You all can see slowly the gas bubbles starting to evolve. Look at the electrodes closely. Near both electrodes, you will see gas bubbles evolving. So here students, you all can see this side I said is the negative terminal. Can you see the gas bubbles evolving a bit more faster? Here it's not the rate of reaction, it is the volume of gas that is going to be evolved. You will see a difference, you have to notice that as well. Near both electrodes, you can see gas bubbles evolving, but here you can see it coming. We will have to wait for some time until the water gets displaced. When the gas bubbles come up, water is pushed down or displaced down and the gas collects over water. You will be able to see that with time. So in this solution or the liquid, here it is acidulated water, what are the ions present? From water we get H plus ions and OH minus ions. There is a small amount of H plus and sulfate ions from sulfuric acid as well. But here the main ions are H plus and OH minus. So the H plus ion is attracted to the negative electrode and the OH minus ion is attracted to the positive electrode. So that is where the oxidation and reduction will take place. So when H plus ions get attracted to the negative electrode, they take up electrons and they can become hydrogen gas. So that is reduction. So there it is the cathode where reduction takes place. So this will be the negative electrode, the cathode where hydrogen gas is evolved. And on this side, we have the positive electrode. So the OH minus ions gets attracted to the positive electrode and there OH minus loses electrons and gets oxidized. So here oxidation takes place, therefore it becomes the anode. The negative electrode is the cathode and the positive electrode is the anode. So in both you can still see the gas bubbles coming up. We will have to wait and see whether equal volumes of gas is collected or not. Okay, so now can you all see students, after some time, now this is near the negative electrode, that is the cathode. So here you can see more volume of gas has been collected, whereas near the positive electrode, that is the anode, there is less amount of gas collected. So you all can see the difference and still the gas is being collected. Here you can see the gas bubbles moving. Here also you can see the gas bubbles coming up. So still the gas is being collected. Like this, if we keep it for a longer time, you will get more gas being collected inside the test tubes. So we'll wait for some more time. Okay students, so now I let the electrolysis to occur for some time. Now here you can see this of course is about half filled with gas. So here you can see students the negative electrode, that is the cathode, is completely filled with gas. The test tube that is covering the cathode is completely filled with gas. So you all know this is hydrogen gas and this is oxygen gas. But to confirm that the gas evolved near the negative electrode or the cathode is hydrogen and the gas evolved near the positive electrode or the anode is oxygen, we can carry out the test. You all know the test. When we insert a burning splinter, what happens if it is exposed to hydrogen gas? At the same time, to test for oxygen gas, what do? We insert a glowing splinter. So to do that, I will have to first take out the test tube out of water. But I have to make sure that the gas does not escape from the test tube. So here you can see now I have the gas inside this. So we need to insert a burning splinter into this. Okay, so I have the test tube with hydrogen gas and now I am going to make a burning splinter. This is a dry eagle. I will hold it to the flame. So while the flame is on, we have to. So you heard the pop sound and the flame goes off. So that is how we identify that it is hydrogen gas. Now still the oxygen gas is filling into the other test tube. We will test that as well. Okay students, so still you all can see the gas bubbles evolving near the negative cathode. So you all know that it is hydrogen gas. We heard the squeaky pop sound when I inserted the burning splinter. Now I have the oxygen gas collected in the other tube, the second test tube, that is covered over the positive electrode, that is the anode. So again I'll have to take out the test tube, making sure that the gas does not escape from the test tube, and then I will need to insert a glowing splinter to observe and confirm whether it is oxygen or not. So now I'm going to take out the test tube, making sure the gas does not. Here I have the gas collected from the positive electrode, that is the anode. So you all know it is oxygen. We have to insert a glowing splinter. So now to burn this, you only need the glow at the tip. And when you insert it into the tube containing the gas, you have to observe what. Can you all see? It rekindles. So you all saw that the glowing splinter rekindles and relights. So that confirms the gas collected in this is oxygen gas. So we did the electrolysis of acidulated water, and from there we saw that you all were able to see that the gas is evolved from both the electrodes, and near the negative electrode there was more volume of gas, or we can take it as double the volume than that is evolved at the positive electrode. And near the negative electrode it is hydrogen gas, because the H plus ions go towards the negative electrode, they migrate towards the negative electrode, there they undergo reduction and become hydrogen gas, and that is what we collected and we confirmed it using the burning splinter. Burning splinter, when you insert it, it burns off with a squeaky pop sound. Then the gas that was collected near the positive electrode, that is half the volume compared to the other gas, and that is oxygen. So there OH minus ions migrate towards the positive electrode and there it undergoes oxidation, therefore it is the anodic reaction. And we confirm that it is oxygen using the glowing splinter. You saw the glowing splinter relight and rekindle. So from that we confirm the two gases evolved. So those are the observations of electrolysis of acidulated water. Okay students. So did you all see the observations clearly? What happened there? When I did the activity, you were able to see that there were gas bubbles evolving near both the positive and negative electrodes, and also you were able to see that the gases got collected over water inside the test tube. That is what you call as downward displacement of water. So you're familiar with that. So gases collected by downward displacement of water. And also you were able to see that near the negative electrode, there was more volume of gas collected, whereas near the positive electrode, there was less volume of gas collected. So those were the observations. Then you can remember, I tested the gas that was collected near the negative electrode. What did we do? We inserted a burning splinter and you were able to hear the squeaky pop sound. So from that, what did we confirm? That the gas evolved near the negative electrode, that is the cathode, is hydrogen gas. And also I told you all that the gas evolved near the positive electrode is oxygen gas. I'm sure you all can remember all those observations. So we will write them down here. So here, gases are liberated near the electrodes and are collected in the test tube by downward displacement of water. Downward displacement of water. More gas is collected near the negative cathode. You can say negative electrode or cathode. I have included both so that you remember negative cathode. And less volume of gas is collected at the positive anode. If you really look at the volume of gases, of gas anode to cathode, you were able to see it was 1:2. Near the cathode, it was 2 volume of gas, whereas near the anode, it was just 1 volume of gas. Then, what did we do? A squeaky pop sound was observed when the gas collected at the cathode was tested with a burning splinter. So you all are familiar with the tests that are carried out to identify gases. So normally we use a burning splinter to identify hydrogen. And if it is hydrogen, it burns with a squeaky pop sound. So that was observed. So if you want to test the gas evolved near the negative electrode, that is the anode, to test whether it is oxygen, what do we do? we need to insert a glowing splinter so that if it is oxygen, it will relight and burn. So that is how we confirm the oxygen gas. So in this activity, these are the observations. Gases are liberated near the electrodes and are collected in the test tube by downward displacement of water. And then more gas is collected near the negative cathode and less volume of gas is collected at the positive anode. So volume of gas near the anode and cathode, if you look at it, it is like 1:2 volume. And a squeaky pop sound was observed when the gas collected at the cathode was tested with a burning splinter. So this was the squeaky pop sound that was observed when the gas collected at the cathode was tested with a burning splinter. Now the same way, what did we observe with the other gas? The gas that was collected at the anode. We inserted a glowing splinter into it, and then you were able to see that the glowing splinter relighted and it burned well. So from that, what did we conclude? We concluded that it was oxygen. So there, the next observation, the glowing splinter relighted, or you can say rekindled. You can use either one of the words, relighted or rekindled, when inserted into the gas collected at the anode. So that was the other observation you all were able to see. So from this, we were able to conclude that the gas evolved at the cathode is hydrogen and the gas evolved at the anode is oxygen. So I will write that also here. Conclusion: gas liberated at the cathode is hydrogen and gas liberated at the anode is oxygen. So that is the observation and conclusion. We will quickly look at it once again. Observation. So you see gases are liberated near the electrodes and are collected in the test tube by downward displacement of water. And also you were able to see more gas is collected near the negative cathode and less volume of gas is collected at the positive anode. So volume of gas, the ratio was almost 1:2. And also a squeaky pop sound was observed when the gas collected at the cathode was tested with a burning splinter. The glowing splinter relighted, or you can say rekindled, when inserted into the gas collected at the anode. So from that, we were able to conclude the conclusion: gas liberated at the cathode is hydrogen and gas liberated at the anode is oxygen. Now in this also, we need to understand the reactions related to electrolysis of acidulated water. So to do that, here of course students, I am not going to draw the electrolytic cell. I will explain the process because this is acidified water, acidified or acidulated water. So what are the ions present? Now water is H2O liquid. Now earlier we discussed in the memory file also, you can remember students, the dissociation of water is very much less, but still For our convenience, we will use the oxidation and reduction reactions using H plus and OH minus ions. We will not use the other two reactions that we discussed under memory fund. So water, we will consider it as dissociated because of acid due to the acidification of water. So here you consider that the acidified water dissociates to give H plus and OH minus ions. So H plus aqueous and OH minus aqueous. So here H plus ions, the positive ions, get attracted towards the negative electrode. That is the cathode. You can remember it is the cathode. And near the cathode, H plus ions will take up electrons, and here to balance it we need to have 2H plus 2 electrons to give rise to H2 gas. Then near the positive electrode, that is the anode, what will happen? OH minus ions will go towards the anode. You can remember the equation, 4OH minus ions giving rise to 2 water molecules. O2 gas releasing 4 electrons. So here also you can see, students, the number of electrons. This is 4 electrons. Here it is 2 electrons. So if we label these as 1 and 2, we need to multiply equation 1 by 2. So then you will get the equation as 4H plus aqueous plus 4 electrons gives rise to 2H2 gas. So if we take this as the third equation, then if I add 2 and 3, you will get 4H plus aqueous plus 4OH minus aqueous. So here we have 4H plus aqueous, 4OH minus aqueous, and we need to have 4 electrons. That will become 2H2O liquid plus O2 gas plus 2H2 gas, and there will be 4 electrons. So in this, now you can see here we have 4 electrons, there also we have 4 electrons. So the electrons will get cancelled off. So then of course we will get the final equation, 4H plus aqueous plus 4OH minus aqueous giving rise to 2 water, liquid, O2 gas and 2H2 gas. So now you can see we have H plus and OH minus from water. Here also there is water produced. So finally if you look at it, water is being converted to oxygen and hydrogen. So in this, now you all can observe, students, oxygen 1 volume, whereas you have hydrogen 2 volume. So now can you all understand the ratio? 1O2 to H2. That is why you get 1 volume of oxygen near the anode. That is the positive electrode. And near the cathode, you get, that is the negative electrode, you get 2 volume of hydrogen gas. So if you are asked to explain that, you have to write this equation. In that you can show the ratio as O2 is to H2, 1 is to 2. Therefore, near the anode, there is 1 volume of gas collected, and near the cathode, there is 2 volume of gas collected. Because the ratio between these two is 1 is to 2. So, that is how the reaction takes place. Is that clear to you all, students? So, quickly I will explain the reactions one more time. So these are the conclusions. From there, if we looked at the changes when it is acidified water, water liquid dissociates to give H plus aqueous and OH minus aqueous. So near the negative electrode, it is the H plus ions taking up electrons and forming H2 gas. The reduction. And near the positive electrode, anode, the negative ions, OH minus ions get oxidized to water, oxygen and losing 4 electrons. To balance them, we need to multiply the first equation by 2 because there are 2 electrons there and 4 electrons here. So when you do that, you get the equation as 4H plus aqueous plus 4 electrons giving rise to 2H2 gas. Then you can see here when you add 2 and 3 together, you can see students 4H plus aqueous plus 4OH minus aqueous plus 4 electrons giving rise to 2H2O liquid, O2 gas and 2H2 gas plus 4 electrons. The electrons get cancelled off and finally we get this electrolytic equation. 4H plus aqueous plus 4OH minus aqueous giving rise to H2O liquid, 2H2O liquid, O2 gas and 2H2 gas. So if you look at the ratio between oxygen is to hydrogen, you can see 1:2. So 1 volume of oxygen, 2 volume of hydrogen. So near the anode, we get less volume of gas liberated, while near the cathode, we get more volume of gas liberated. That is in the ratio 1:2. And by testing for the two gases, we confirm that they are oxygen and hydrogen respectively. So now you all can understand what happens when we electrolyze acidulated water. So here students, this is the final equation that we got in this. Now you all can see that we have both H plus ions and OH minus ions. So if we add them together, what is this going to be? You will get 4H2O liquid. H plus ions and OH minus ions together, you will get 4H2O liquid. But here you can see there are 4 water molecules. Here there are 2 more water molecules. So because of that, we can simplify this and write the final equation this way. So we can have 2 water liquid giving rise to O2 gas plus 2H2 gas. The same equation, but we simplify it and write it as this. So this will be the final equation for electrolysis of water. You have to remember that. 2 water liquid giving rise to O2 gas and 2H2 gas. And from this, you can easily understand the volume ratio between O2 and H2. This is 1, this is 2. So since the ratio is 1:2, the gases are also collected in that particular manner. So you have to understand this, students. So here in this one, I have explained how we get the equation, but finally you all can understand that from water, 2 H2O liquid, 1 oxygen gas and 2 hydrogen gas is produced. So that is how the reaction occurs. I am sure you all can understand that. So with that, I will move on to the next slide where I will discuss the reactions related to electrolysis of acidulated water in order again. Reactions at the negative electrode, that is the cathodic reaction. So here, which ions in the solution migrate towards the negative electrode? The positively charged H plus ions in the solution migrate towards the negative electrode and get reduced receiving electrons. So those are the terms you need to remember. H plus ions, they go towards the negative electrode and they get reduced receiving electrons. So you all know the equation. 2H plus aqueous plus 2 electrons give rise to H2 gas. And we took this as the first equation. And as this is a reduction, this is the cathodic reaction. Hence, hydrogen is liberated at the cathode. So, these are all what we discussed before. So, here you can see this is a reduction, this is the cathodic reaction, and hence hydrogen is liberated at the cathode. Hydrogen is liberated at the cathode. Then, we will move to the next slide. So, here reaction at the positive electrode, that is the anodic reaction. The positive terminal attracts sulfate and OH minus ions in the solution. Now, I did mention this before, students. You all can remember this is acidulated water. So, how do we prepare acidulated water? By adding dilute sulfuric acid, H2SO4. Now, you all know dilute sulfuric acid is a strong acid. So, because of that, it dissociates completely to give H plus ions and sulfate ions. So, near the negative electrode, there is no problem. H plus from acid, H plus from water. So, that is what gets reduced. But there are two negative ions in the solution. One is sulfate ion, the other one OH minus ion coming from water. So, out of that, you are familiar with this. When there is sulfate ion and OH minus ion has the tendency to get oxidized. So, you can remember that. H2O gives rise to H plus and OH minus. So, when we have these two, sulfate and OH minus will get oxidized. Normally, sulfate does not get oxidized. So, if we look at the reactions, the positive terminal attracts sulfate ion and OH minus ions in the solution. Of these, the ions tend to undergo, I repeat, of these, the OH minus ions tend to undergo oxidation preferentially. So, here it is the oxidation of OH minus ions. So, you know the equation for OH minus aqueous gives rise to 2H2O liquid plus O2 gas losing 4 electrons, and that we will take as the second equation. Now, because this is an oxidation, so here you know, because this is an oxidation, reaction 2 is the anodic reaction. Thus, the positive electrode is the anode. So, something that we discuss. Then, oxygen gas bubbles are liberated at the anode. So, that is the other point you need to remember. And electrolysis of water on the whole can be represented by the following equation. So, here we need to write the equation. So, here like a final equation, what we can write is, we had water, H2O liquid, that gets 2 H2 gas and 1 O2 gas. So, we need to take 2 water liquid. 2 water liquid, that becomes H2 gas and O2 gas. And you can remember, H2 is evolved near the cathode, that is the negative electrode, and O2 is evolved near the anode, that is the positive electrode. Is that clear, students? So, these are the reactions taking place during electrolysis of acidulated water. So, from water, we get H2 gas and O2 gas. So, now from all these observations, students, all these different types of electrolytic processes, I am sure you all have a very good idea as to what electrolysis is. That is, by passing electricity, by supplying electricity, we make a non-spontaneous chemical reaction to take place. Now, this reaction, water being separated into H2 gas and O2 gas, it is not a spontaneous reaction. It is a non-spontaneous reaction. You can't make it to happen easily. But by passing electricity, by supplying electricity in an electrolytic cell, we make this to happen. So that is the process of electrolysis. I am sure you all can understand that. With that, students, I am going to end this chapter, and in the next chapter, I will discuss some applications of electrolysis.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.